Okay. Okay. Part 5. 390 facts, the making of. We are now inside of the base template, if you would, HTML file for the Khan Academy Exercise Framework Generator. And we're looking at here editing one that's already there. And so this was kind of, we're going to eventually have this named MJP something. So these naming structures are going to become important. I'd forgotten about that when I named it 390. So this idea that all of Mark J. Patak stuff will be there, and then a whole series of starting from 0 to 1,000 basically are going to be subdirectories underneath. So we'll go back and fix that. But I want you to look at right now this data structure here and how we'll just right away get it started. The first value is the value of the selection. So E, I, pi, -1, and these are text selectors, -1, 0. Okay, and over here on the right I'm going to fill this in because this could be one way to generate without writing questions. So this would be used for doubling growth in our case. I would be square root, even though this isn't quite square root of -1. Actually, the way it's better defined is actually because it has a number of square roots. It is I squared equals -1. Pi is ratio of diameter, ratio of circumference, circum to diameter. And of course, -1, in this case, flips is what I want. Flips something. That's what multiplying by -1 does. It flips something, and 0 is the additive identity. So obviously there's more to do. I won't go through all of them here. I'm going to kind of pull this out a little farther so you can see in the end, if you kind of lay this out correctly, you can kind of have a per one per line, and then here this last entry is actually going to be the answer if you actually were going to select for one of these. So you're going to have some data structures built up here. What I want to now point out, I'm going to jump over within this frame to two other programs, this one there and this one there. All right, so hopefully you can see that, and I'm going to point out I then have gone back into the base document, which is the picture editor, whatever that would be, in this case Smooth Draw, and I'm pulling off the X and the Y coordinates based on the top left-hand coordinate system. Basically the way you deal with images is that way, a little bit different from what you're used to in standard math. And the coordinate here, I'll pull this up here, if I go over the top there, you see the coordinate is 169, 374, 314 more or less. And over here I've started to build a Google document to keep track. So 171 and 315. And what you'll see later, as long as you're close, there's going to be, so as long as you're close to that, you're going to give obviously some error to the where the student brings the, or the learner brings the dot. So I've pulled off each of those. Let's see how I did on the next one. In the center of that, it reads 183 and 258, and that's what we've got here. So I've got the data pulled off, something you can hand off to others. Once again, something that a program could do. It's called Morphology Tools in Mathematica, or I'm sure as well Processing JS is how I'm going to try to learn to do this, which is the programming language underneath Khan Academy Computer Science, also the programming language back behind Arduino. The medium is the message. So with all that taken into effect, I'm going to go ahead and file exit out of this one and kind of just start transcribing some of these now. So the way this is laid out, it turns out, is, getting that all on the page here, is the answer, E, or the particular selection, so that you can see not what coordinate people grabbed, which is sometimes important, but more importantly, what was the thing that was at that coordinate. This is a function that does the flipping and the shifting that takes it from a left-hand coordinate system to a right-hand coordinate system. And you notice here, I'm keeping you at 640 by 480, but you should be able to use another capture as well. I would stick with this if I were you. We'll see later why. This is the basic coordinate left and right and up and down of the quote-unquote math. If you think about it, the other coordinate system, this is a 640 by 480 is mapped to a 16 by 12 in the program. This tells you that in fact you are flipping, but the important numbers to change here are there. So I'm going to go here and I'm going to go back, and for that one per se it's 171 315. So I'm going to go in here and type 171 and 315. And I'll go ahead for the next one as well. I'll just do 3 in this video. You get the kind of point. The next one is 182, 258. 182, 258. Now you're going to see, if in fact I'd used a true circle, these are all calculable because I have gone every 30 degrees on a circle, centered at a certain point, at a certain radius. So these are calculable because of the way I sketched it, kind of basing on what Udacity does. There's more work here that necessarily needs to be done. So you could set up a number of different templates to work off of so you don't have to put in these coordinates, because this is one of the more arduous things to do. I'm losing my thing. So my third one is 220 by 230. That was pi. 220. And in reality, looking at 330. And the next one was, going back again, 220 by 230. So I'm going to go like that. 230. You know what happens each time I go in here? It kind of flips that back out. The fourth one, which is -1, is 288, 215. So 288 and 215. Well, that was weird. And let's see, 288, 215, and 348, 229. 348, 229. Now, as we've laid these out, you're going to see here, as I kind of try to do an edit here, I'm going to grab a whole line, right? I'm going to edit copy, hit a return here, and then edit paste. And you can see that you can go on down the line. So after EI pi -1, 0, this is 1, right? And this is the multiplicative identity. Multiplicative identity. And more importantly, or equally important, we want to get the coordinates on that. EI pi -1, 0, 1, 379, 275. 379, 275. So that's the drill. Okay, so later on, again, to review, this is the most significant editing you're doing in these files. You're putting the answer and the coordinates of the answer, and in the end, even a question over here for when you want to auto-generate without doing the kind of written generation that we're doing here. This down here then becomes a potential place to put the answer. So in this case, we might want to go ahead and put the answer that we want, in this particular case, as E. So laying things out this way is going to let you very quickly scale up a whole lot of questions. There are two ways to go about getting a reasonable set of infinite tutor questions. One is to make them mathematical enough that the program can present different numbers to students or learners. And the other one is just to generate enough questions, enough specific questions per one idea for the computer to kind of randomly throw things at the student. An example for E, lots of definitions. What symbol is tied to a function that the slope is equal to the value of the function? E. What symbol is calculated by 1 plus a very small number to an infinite power? The answer is E. What symbol is the letter after the letter D? E would be the answer. So you can be more creative than me on that. So the question can be added later on. You can go and add right here. You can add these in some other basically list, so it can generate more than one question, and immediately you can probably generate 130 questions off of about the same work as we're generating these 13. So thanks for listening. We're going to save this once again. We'll go back and try to actually get this working the next time. I'm going to edit the rest of these out off camera. You don't need to see me doing it. What you have is a particular format here, so that you can really keep track of the plane. A picture is worth 1,000 words. Keeping track of things and your file set, you can reuse things later on. You have these coordinates signed. You could come back into this picture here if you would, which we've lost already, and just edit out some of those answers. That's what I will do eventually, as I have tied a lot of my learning with my kids into 13 things at a time, corresponding to the 13, I guess, spots on a clock, but more likely to the 13 spots if you go from the west to the east and break up the world into 1 hour of rotation, pi over 12. That's why the circle. Thanks for listening.